Morning students, welcome back to the physics class. Now we are starting with chapter number 4, magnetic effect of a current. Okay, so we are starting with the topic of a very first one, that is Orested experiment. So already we discussed this topic, Orested experiment, in our standard 10th. So let's take what we have done. Very simple topic. So what we discussed in the 10th standard, see, suppose I have a current carrying conductor over here. This wire is connected with a battery, so current is flowing from positive terminal to negative. So this is a direction of a current. Okay, so in 10th standard what we have done, so we know the direction of a magnetic field with the help of a swimming rule. Okay, swimming rule. What is that swimming rule? So suppose a person is swimming in this direction, then magnetic field can be calculated on the left side. This is right portion, this is left portion. So how to learn this? So where the current is entering, that is south pole. Where the current is existing, that is north pole. So always we'll find out the magnetic field on the west direction. Okay, always west. So this is a very simple trick to understand. Okay, current enter south, exist north. So always magnetic field will be found with the help of a west direction, always in the west direction. Same to same you can see, current is moving, this is south, this is north, so magnetic field is always perpendicular. So this is we have to keep in the mind. So what we understood over here, a magnetic field can be generated by two things. One is magnet and second one is by current. So if a current is flowing, it generates magnetic field. What is the direction? West side. Okay, now we have understood there are so many topics related in this. So what is the note over here? This discussion will say that a magnetic field is not generated only from the magnet. We can generate by current, or we can say current means moving charge. Okay, charge means charge particle. So we can say sources are two. One is current and second one is magnet. So what is magnetic field? So magnetic field means the space around the current carrying conductor. So this is the current carrying conductor. The space around the wire is nothing but effect like a magnetic field. Okay, so up to which it can attract the material. So if we put any material over here, it can simply attract. So we can say the region around the wire is nothing but called magnetic field. Same to same, it is just like if we have a magnet over here, so space around the magnet is called magnetic field. It is very easy to be understood with you. Now if you understood with this, now let's take some good SI unit of this. So what is the SI unit of magnetic field? Tesla. CGS, Gauss. So we have a relation for Tesla and Gauss, just like you can know 1 kilogram is equal to 1000 kilogram, 1 kilogram is equal to 1000 gram. So it is a relation between kilogram and gram. Same to same, 1 Tesla is equal to 10 to the power 4 Gauss. Now if I want to calculate in gram, so what should we do? Taking 1000 over here, so 1 upon 1000 is equals to this. Same to same, take this is over here, I am taking in here. Now do one thing, denominator to numerator, the sign will change, it become -4. So 1 Gauss is equals to 10 to the power -4 Tesla. Very simple, very interesting. Now what is magnetic field? So we know that in a magnet, inside the magnetic field is flowing from south to north. Okay, and from outside it is north to south. So what is the meaning of this? The meaning is this: magnetic field forms a loop. Magnetic field forms a loop. Inside south to north, outside north to south. One more thing that we have to keep in the mind: inside the magnetic field, inside the magnetic fields are uniform, they are equidistant. So we can say magnetic field inside the magnet is uniform, but outside it is non-uniform because the distance is diverging, distance is different. So we can say this is non-uniform magnetic field. Simple hai, very easy. Now let's move to the dimension of a magnetic field. So what is the dimension of magnetic field? See, suppose I have a current carrying wire, current flowing I. Magnetic field is produced on the west side. This is south, this is north, so we can calculate magnetic field here. Okay, and length of the wire is L. So we have a relation F is equals to BIL. Don't worry if you are not able to understand, because we have a whole derivation of this. So just now keep the formula in the mind. F is equals to BIL, magnetic field, current, length. Now I am interested to calculate the dimension. So take this IL as a denominator over here. Now see, B is equals to F upon IL. See, now put the value of force. Current is measured in ampere, length is meter. Now simple mathematics, solve this and you are able to get the magnetic field dimension is M L0 T minus 2 A minus 1. So this is a magnetic field. I hope you are able to understand. Thank you so much.